Hello students, in my previous video I gave you 3 questions for the homework. Let's start this video with discussion on the previous question, homework question. The first question was that find the dual form of x and y or x and y naught is equal to x or y. What is dual law? The law of duality or dual law is, it states that you can change AND operator into OR operator into AND, 1 into 0 and 0 into 1 and not remain unchanged. That's a law of duality. AND into OR into AND, 0 into 1, 1 into 0, not remain unchanged. So applying that law, what is the dual form of this? X and changes into or change into AND, X and change into or, y naught will remain y naught, X or changes into AND, 0 changes into 1. So this is the law of duality we have applied in this. So this expression dual is this expression. Second question I gave you the homework is, if f is this, find the f naught. Find f naught when f is equal to this. F naught means find the complement of the expression. Now f naught means this particular expression. This is f and we have to find f naught. So f naught means the entire this particular term naught. So we apply De Morgan's here, and if we apply De Morgan, break the line, change sign, 1 naught comes here, a naught, b naught, c naught, whole naught, a naught, b, c naught, whole naught, and change the sign or change it into AND. 1 naught comes here on this term, another naught here, and this change the sign. Again apply De Morgan here, break the line, change the sign, a double naught or b naught naught or c naught naught, and this is a naught naught or b naught or c naught naught. This is also De Morgan's law. And now double naught we cancel. This is involution law. Involution law, this is a or b or c, and this is a or b naught or c. So this is the complement of the given expression. Now the next is your question number 3, which is this, and it says that simplify this particular expression. If we simplify this expression, look at this particular expression here, apply distributive a and a naught or a and b. Remaining expression copied as it is, and a naught is 0 and 0 or it's a property of 0 will remain a and b, and what is outside is c and a or b. So this rule we apply here, distributive rule. Then we apply a and a naught is 0. This is complementarity law. 0 or a and b is a and b. This is property of 0. And a and b and c and a. So it's going to be a and b and c and a, or a and b and c and b. So this again we apply distributive, and in one term a and a. Idempotent law. This is idempotent law. You can see here. A and A will remain A, idempotent law, A, B, C. Here you have B and B will be writing it once, idempotent law. Idempotent law A, B, C or A, B, C is A, B and C. It's again idempotence law. So the simplified form of this expression is A, B, C. Okay, now the next topic in this chapter is derivation of Boolean expression. So what does it mean, derivation of Boolean expression? In this we'll be discussing about the various terms we can create in Boolean algebra. So the Boolean terms we can create, mainly the 2 terms are there, min terms and max terms are the 2 terms we can create in Boolean algebra. Here we are using 2 variable example, min term and x term. This is I am using in taking example of 2 terms AB. You can take 3 variable, 4 variable examples also. AB example I am taking 2 variable literals. So min term, what is min term? Min term is nothing but the product of literals. Literals are AB here. A and B are the literals. Product of literals. So the product of literals, the first minterm using AB is A and B. Second, we can create another minterm using AB variable is A and B naught. Third, we can create is A naught and B. All these are minterms. Can we create more? Yes, we can create one more, that is A naught and B naught. So for two variables, we can have maximum 2 to the power 2, that means 4 minterms. What about maximum? Maximum is sum of literals. So what the first maximum here using AB is A or B, A or B naught, third A naught or B, fourth A naught or B naught. So these are the minterms and maxterms. Using these, if you combine minterms, if you combine these minterms, what you will get? You will get SOP expression. SOP means sum of product. What is the sign for SOP? Sigma. Sum of product. Where is the product term? These are the product term. Their sum. So the SOP expression is A and B, or A and B naught, or A naught and B, or A naught and B naught. This is sum of form, SOP form. If you combine these 4 max terms, you will get POS expression. The sign used is pi. And product of their product. So A or B, whenever you write a OR term, use bracket in that. Enclose always OR term in bracket. A or B and A or B naught and A naught or B and A naught or B naught. So this is POS. POS means product of sum. So this is a product of sum form. And in one SOP expression, this is SOP expression. In this SOP expression there are 4 terms, and in all 4 terms both the literals are present. AB, 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 AB. Such expression is called canonical SOP expression. Canonical. Look at this. In this POS, there are 4 terms. In all 4 terms, two variables are present, AB. So this particular expression is considered as canonical POS expression. Canonical POS. This something called cardinal expression, cardinal form. So what is cardinal? Let's see now. Okay, how can we find the cardinal form from a canonical form? Let's understand. Cardinal means the representation of any expression not in terms of literals but in numeric representation. Whenever you are representing a Boolean expression in its numeric form using designation, that is called cardinal. How can we convert a minterm or maxterm into its equivalent numerical value, which is called designation? In that, remember one thing, minterm will be replacing all AB such like terms with 1 and not terms here with 0. Remember that? And here we have a representation like this. AB will be represented with 0 and not term here represented with 1. So that you can, this is one way of understanding this. There is another method, but let's understand the first one. In this case, AB. So I told you AB, the AB will be equal to binary value equal to, what is binary value? Is 1 1. Its binary value will be 1 0. It's 0 1 and it is A naught. Naught is represented with 0 0. These are the binary values. And in class 11 we also have discussed how can we convert binary to equivalent decimal form. So how can you convert this into binary to equivalent decimal form? This into 2 to the power 1 plus this into 2 to the power 0. 2 to the power 0 is 1, 1 into 1 is 1 plus 2 to the power 1 is 2, 2 into 1 is 2 is equal to 3. And this is represented as M3. Its designation is 3 or M3. So in place of AB, what I can write is small m3. Look at this. 2 to the power 1 plus 2 to the power 0. 0 into anything will be 0. and 2 to the power 1 is 2. Answer is 2. It's M2. So A B naught can also be written as M2. 2 to the power 1, 2 to the power 0, it is 0. 2 to the power 0 is 1, is equal to 1, and M1. And this is 2 to the power 0 and 2 to the power 1, this is equal to 0, it's M0. So A, B or AB naught or A naught B or A naught B naught, this is a canonical SOP expression. M3 or M2 or M1 or M0, this is a cardinal form. And this cardinal form can also be represented as summation of sigma, sum of, and cardinals are, these are the cardinals. How can we have a cardinal representation in case of this? What I told you, AB is non-complementary term represented with 0. 0, 1 and naught will be with 1. 1, 0 and 1, 1. So this is again 2 to the power 1 plus 2 to the power 0 is equal to 0. And this is equal to M0, capital M0. 2 to the power 1, 2 to the power 0, 0 plus 1 is equal to 1, capital M1. 2 to the power 1 plus 2 to the power 0 is 2 plus 0 is equal to 2 is M2. And 2 to the power 1, 2 to the power 0, 2 plus 1 is equal to 3 is capital M3. So A or B can be written as M0, M1, M2 and A naught or B naught is M3. This is cardinal form and this is product of. Pi is a sign of product of 0, 1, 2, 3. So A or B and A or B naught or A naught or B and A naught or B naught. This is canonical POS form. But when you are representing it in terms of this or this, it's considered as cardinal form. There is a cardinal representation. I hope this topic is clear. Next topic I will discuss in my next video.